Hello Chem 1, today is the last day of Unit 1 in terms of new information. Hopefully at this point you've had a lot of new math and we can hopefully get on to the chemistry in Unit 2. Today we're going to cover dimensional analysis, which is the way to basically convert from one number to another or one unit to another. Let's get started. So honestly, you already know how to do dimensional analysis. If I told you how many inches are in 3 feet, you would say, okay, there's 12 inches in 1 foot. 3 times 12 is 36. That's 36 inches. That's dimensional analysis. Now that's very simple dimensional analysis with numbers that you're very familiar with. But dimensional analysis is just using conversion factors, 1 foot equals 12 inches, to convert from one unit to another. That's all it is. It gets more complicated when you're dealing with numbers you're not familiar with, which will happen this year. So let's practice some dimensional analysis. These are conversion factors that you might need to know. You do not need to memorize them. They are on your equation sheet. I will never ask you to produce a conversion factor that is not in front of you. So we got things based on volume. Okay, we've got things based on mass and weight. We've got things based on length. We've got things based on, there's some more volume. Okay, so there's all kinds of different numbers that we can convert from and to. Here's some helpful hints with dimensional analysis before we get started. Step 1, state the given. Step 2, whatever unit you're trying to eliminate or convert from should go on the opposite side of the dividing line. What does that look like? It looks like this. Let's suppose I said how many seconds are in 2 years. You have years that you're starting with. This is my given. And then I put years at the bottom, and that way years will cancel out. So we go from years to days, then from days to hours, from hours to minutes, and then from minutes to seconds. And these are all conversion factors that are helping us get there. I know that's really fast. Let's do a couple examples here real quick. Real straightforward. 320 inches is equal to how many feet? The first thing you're always going to do is state the given. 320 inches. I know before I do anything else that I want inches to drop out, so inches will be here at the bottom. This term here, this measurement and this measurement during dimensional analysis will always be the same because you want it to cancel out. And then wherever you're trying to get to, which in this case is feet, that goes on the top. And now we need a ratio of feet to inches. Common mistake here, people do stuff like this. 12 feet is not 1 inch. That doesn't make any sense. You need to make sure that the numbers you're using go correctly in the correct spots. Because now that we have this set up, if the number is on the numerator, we multiply it. So 320 times 1. And if it's on the denominator, we divide by it, divided by 12. So 320 divided by 12 is 26.6 repeating. But I started with 3 sig figs. So I want to end with 3 sig figs. So this will become 26.7. Why is it sig figs? Because this is multiplication and division. And with multiplication and division, with all dimensional analysis, however many sig figs you start with, that's how many you're going to end with. So this is kind of a cleaned up version of that math. 17.4 hours is equal to how many minutes? First thing, we always is record the given, 17.4 hours. And now, before we even look at where we're going, I know that hours has to be down here. Has to, because we're trying to cancel it out. And we're going to go from hours to minutes. And I know that in 1 hour, there are 60 minutes. So in this case, the way you would type that into your calculator is 17.4 times 60 divided by 1. And so this is what we would get. And just to be clear, you don't really need to put divided by 1 into the calculator because anything multiplied or divided by 1 is the same. So this is what we get as our answer, but this has 3 sig figs, so our answer needs 3 sig figs. This is going from inches to miles. Now, your first inclination here is, well, I don't have a conversion factor to go from inches to miles. This is one of those problems where you'll have to go step by step. So, same thing, we are going to write down our given. We're going to include the units, because that's what helps us know what numbers we need. So inches is going to go down here. So I can't go directly to miles. So the question should be, where can I go? And I would say the most logical choice would be feet. And then we'd add a second conversion factor because we want feet to go away, and then we can go from feet to miles. The reason we can see this is because if you go back to your conversion sheet, or your equation sheet, you can see that we have a conversion of 1 mile equals 5,280 feet. And you know that there are 12 inches in a foot. So now we're back here, and we can see that 1 foot equals 12 inches, and that 1 mile equals 5,280 feet. The way we would type this in, 1.48 million divided by 12 divided by 5,280. And you should get 23.4, which is 3 sig figs, just like our answer we started with. Another thing we can do, which is less common in this class, but it's good practice, is to take something with a combined unit and convert it. Number 4 here is miles per hour. The way we would write that given is 35 miles per 1 hour. Because that's what miles per hour is. It's telling you how many miles you can travel in 1 hour. And it wants us to get to feet per second. So there's 2 units here we have to deal with. And the key is just deal with them one at a time. So for instance, if I go from miles to feet first, and I know that 1 mile is 5,280 feet, that'll get me to feet per hour. That's what, if I would do this math, I'd get to feet per hour. The next thing I need to do is get from hours to seconds. But notice, hours is here on the bottom. So to get it to cancel out, I need to put hours on the top and then seconds on the bottom. And 1 hour equals 3,600 seconds. And this way the unit of hours drops out. You should always be thinking, where do I need to put this unit so that it will cancel with what's already there? If you're the kind of person, I'm telling you, I get people that come up to my desk and they have no units labeled and all this, and they're like, I don't know what to do. And I'm like, I don't either, because you didn't write the labels. The labels, the units are telling you, okay, this one needs to go here, this one needs to go there. And I'm telling you, I know where we're heading this year, and if you are kind of the person that wants to take shortcuts and not record the units on your numbers, it's going to cause you problems. Trust me. So the way we would solve this is take 35 times 5,280 divided by 3,600, and we'd get 51.3, and that would be feet per second. But this only has 2 sig figs. So we would round it to 51 feet per second. Let's do one more here together. We have 36.2 miles per gallon. 36.2 miles per gallon, per 1 gallon. So the first thing, and it wants us to go to kilometers per liter. So the first thing we want to do is get miles to cancel out and go from miles to kilometers. So now we're in kilometers per gallon. And then gallons down here at the bottom. So gallon's going to go up here at the top. And we're going to put liters down here at the bottom. So in this problem, if you take a look at your equation sheet, you do not have a conversion from gallons to liters. So let's do it a different way. What if we go from gallons to quarts? That is a conversion factor you have. And then you could add on another conversion factor, and I want quarts to cancel out, so quarts goes up here at the top, and I can go from quarts to liters. Now, based on what you have, you can go from 1 mile, which is 1.609 kilometers, And you can go from 1 gallon, which is 4 quarts, and you can go from 1.06 quarts, which is 1 liter. So if you were going to do the math here, you'd take 36.2 times 1.609 divided by 4 times 1.06. And the answer you would get is 15.435. Our given only has 3 sig figs, so that means our answer should only have 3 sig figs, and that would be kilometers per liter. So you can see, theoretically, these problems can get, I don't know if I'd call them complicated, but you can build a very long problem depending on the units you're converting to. You need to know how to do both kinds. It's good practice, but understand that most of what we're going to spend time on is not compound units. I'm going to let you go over these last 2 problems here by yourself, see what you can come up with, and then come to me and we can check over your answers. Keep working hard. Good job today. We will see you soon.